Top 25 Manufacturing Quality Engineer Interview Questions and Answers. The role of manufacturing quality engineer is vital in maintaining high product standards, ensuring process efficiency, and minimizing defects in production. Employers seek candidates who possess strong analytical, problem-solving, and process improvement skills. In this guide, we present the top 25 manufacturing quality engineer interview questions with detailed 100-word answers to help you prepare effectively and demonstrate your expertise in quality systems, root cause analysis, lean manufacturing, and continuous improvement initiatives. 1. What are the primary responsibilities of a manufacturing quality engineer? A manufacturing quality engineer ensures that production processes meet quality standards by implementing quality control systems, conducting inspections, and analyzing data. They collaborate with design, production, and supply chain teams to improve product consistency, reduce waste, and enhance efficiency. Their duties include managing nonconformance reports, performing root cause analysis, and implementing corrective and preventive actions (CAPA). Additionally, they ensure compliance with ISO standards, develop quality documentation, and support continuous improvement programs to optimize manufacturing performance and achieve customer satisfaction. 2. How do you ensure product quality in a manufacturing environment? Ensuring product quality requires systematic monitoring and control throughout the production process. I apply statistical process control, SPC, regular inspections, and audits to detect deviations early. Implementing standardized work instructions, process capability studies, and preventive maintenance also helps maintain quality. I collaborate with operators and supervisors to reinforce quality awareness, review customer feedback, and utilize failure mode and effect analysis, FMEA, to identify and mitigate potential risks. Continuous improvement and training are key to sustaining high-quality outcomes. 3. What is your experience with ISO 9001 standards? I have extensive experience implementing and maintaining ISO 9001 quality management systems. I ensure compliance by developing and updating procedures, conducting internal audits, and training staff on quality standards. I also monitor corrective actions and measure performance using key quality indicators. My role often involves preparing documentation for external audits, addressing nonconformities, and fostering a culture of quality improvement. ISO 9001 provides a robust framework for consistent process control, customer satisfaction, and continuous improvement across all manufacturing stages. 4. Can you explain the difference between quality assurance and quality control? Quality assurance, QA, focuses on process-oriented activities that prevent defects by establishing systematic procedures, while quality control, QC, is product-oriented and involves inspection and testing to identify defects. QA aims to improve and stabilize production processes to ensure consistent outcomes, whereas QC verifies product conformity with specifications. In manufacturing, both functions work together. QA sets a framework and process standards, while QC ensures the final output meets those established criteria through inspection and testing methods. 5. What quality tools do you commonly use? I commonly use tools such as Pareto charts, fishbone diagrams, control charts, scatter plots, and histograms for problem-solving and data analysis. Additionally, I apply failure mode and effect analysis, FMEA, for risk assessment and statistical process control, SPC, for monitoring production stability. The 5 whys and root cause analysis are essential for investigating recurring issues. These tools enable systematic evaluation of quality data, help prioritize improvement areas, and support data-driven decision-making for process optimization and defect reduction. 6. Describe your experience with statistical process control, SPC. I have extensive experience implementing SPC to monitor manufacturing processes and maintain consistency. By analyzing control charts, I can identify trends, variations, or shifts that signal potential process instability. I use SPC software to track key parameters and trigger corrective actions before defects occur. Training operators to interpret SPC charts ensures immediate responses to deviations. Through continuous analysis, SPC helps reduce variability, optimize process capability, and improve overall product quality and customer satisfaction. 7. How do you handle nonconforming products? When identifying non-conforming products, I first isolate the affected batch to prevent further issues. I then document the non-conformance, analyze root causes, and collaborate with cross-functional teams to implement corrective and preventive actions. Depending on severity, rework, repair, or disposal may be recommended. I also review inspection and process data to prevent recurrence. Communicating findings with stakeholders ensures transparency, accountability, and adherence to quality management system requirements for continuous improvement and defect reduction. 8. What steps do you take to perform a root cause analysis? I begin root cause analysis by gathering detailed information about the issue, including when, where, and how it occurred. Using tools such as the 5 Whys, fishbone diagram, or Pareto analysis, I identify contributing factors. I then analyze process data, operator inputs, and environmental factors to pinpoint the true cause. Once identified, I develop corrective and preventive actions, CAPA, verify their effectiveness, and document all findings to ensure long-term resolution and process improvement. 9. How do you ensure continuous improvement in manufacturing quality? Continuous improvement relies on identifying inefficiencies and implementing corrective actions through Lean and Six Sigma principles. I use data-driven approaches such as DMAIC, define, measure, analyze, improve, control, to improve process capability and eliminate waste. Regular team meetings, audits, and feedback loops encourage engagement. I also benchmark performance metrics, set measurable goals, and recognize improvements. Promoting a culture of proactive problem-solving and empowering employees ensures sustained improvements in quality, productivity, and customer satisfaction. 10. What is FMEA and how have you applied it? Failure Mode and Effects Analysis, FMEA, is a systematic method for identifying potential process or product failures and prioritizing corrective actions based on risk. I've applied FMEA in new product development and process improvement projects to assess failure severity, occurrence, and detection. By calculating risk priority numbers, RPN, I focus on critical areas requiring mitigation. This proactive approach helps reduce defects, enhance reliability, and improve customer satisfaction before production or process changes occur. 11. How do you reduce waste and improve efficiency in manufacturing? To reduce waste and improve efficiency, I apply lean manufacturing principles such as 5S Kaizen and value stream mapping. These help identify non-value-added activities and streamline processes. I analyze cycle times, equipment performance, and material usage to detect inefficiencies. Implementing standardized work, continuous monitoring, and employee involvement ensures sustained improvements. By focusing on eliminating defects, reducing rework, and optimizing workflows, manufacturing operations achieve higher productivity, lower costs, and consistent quality outcomes. 12. What is your approach to supplier quality management? Supplier quality management begins with thorough supplier evaluation and qualification. I establish clear quality requirements, conduct audits, and assess supplier capabilities. Continuous monitoring through performance scorecards, defect analysis, and regular communication helps maintain standards. When issues arise, I collaborate with suppliers on corrective actions and preventive measures. Building strong partnerships fosters accountability, transparency, and long-term improvement. The goal is to ensure consistent material quality that aligns with customer expectations and internal manufacturing requirements. 13. How do you handle customer complaints about product quality? I treat customer complaints as opportunities for improvement. I first document and acknowledge the issue promptly, then investigate root causes using structured analysis tools like 8D or fishbone diagrams. Corrective actions are implemented to prevent recurrence, and the customer is updated throughout the process. I also analyze complaint trends to identify systemic issues. Maintaining open communication, providing data-backed solutions, and ensuring long-term corrective action builds trust and strengthens customer relationships. 14. What is your experience with Lean and Six Sigma methodologies? I am well-versed in Lean and Six Sigma methodologies for process optimization and defect reduction. Using DMAIC, define, measure, analyze, improve, control, I systematically improve process efficiency. Lean tools like 5S Kaizen and value stream mapping help eliminate waste, while Six Sigma focuses on minimizing process variability. By combining both approaches, I have successfully improved yield, reduced rework, and enhanced overall production quality, leading to measurable cost savings and higher customer satisfaction. 15. How do you ensure calibration and maintenance of measuring instruments? I maintain a calibration schedule to ensure all measuring and testing equipment remains accurate and reliable. Each instrument is labeled with calibration dates and tracked through a database. Regular checks verify accuracy, and any out-of-tolerance instruments are recalibrated or replaced immediately. I work closely with metrology and maintenance teams to ensure compliance with standards such as ISO 9001. Proper calibration prevents measurement errors and ensures consistent, trustworthy quality inspection results. 16. How you train employees on quality standards. Training employees is key to sustaining quality excellence. I develop structured training programs covering quality principles, inspection procedures, and documentation practices. Using practical demonstrations, visual aids, and hands-on workshops helps reinforce understanding. I also conduct refresher training after process changes or audit findings. Encouraging feedback ensures employees feel involved and accountable for quality. A knowledgeable workforce reduces errors, increases efficiency, and maintains compliance with industry and regulatory quality standards. 17. What methods do you use for quality data analysis? I use statistical and analytical tools, such as Minitab and Excel for quality data analysis. Techniques like control charts, Pareto analysis, and process capability studies help identify trends and root causes of variation. I interpret data to guide decisions on corrective actions, performance improvement, and process optimization. Regular reporting and visualization ensure management visibility into quality metrics. Data-driven decision-making supports continuous improvement and enhances manufacturing consistency and efficiency. 18. How do you handle production pressure while maintaining quality standards? Balancing production speed with quality is essential. I prioritize clear communication and planning with production teams to ensure quality is never compromised. Using real-time quality checks, SPC, and risk-based inspections allows early detection of issues. I emphasize preventive maintenance, process standardization, and operator training. If pressure escalates, I focus on optimizing workflows rather than bypassing controls. Maintaining discipline under pressure ensures consistent product quality, customer trust, and long-term manufacturing stability. 19. What is your approach to internal audits? Internal audits are critical for maintaining quality system integrity. My approach includes planning audits based on risk, process importance, and past performance. During audits, I review documentation, interview personnel, and observe operations to verify compliance with ISO 9001 and internal standards. Findings are documented, corrective actions are assigned, and follow-ups ensure closure. Audits not only ensure compliance, but also identify improvement opportunities, fostering a proactive and quality-driven organizational culture. 20. How do you evaluate process capability? Process capability is evaluated using statistical measures like CP, CPK, PP, and PPK. I collect data from stable production runs and compare it to specification limits to assess consistency. A high CPK value indicates that the process is centered and capable. I use this data to identify areas for improvement and reduce variation. Regular process capability studies help maintain quality consistency, optimize production performance, and ensure processes meet customer requirements effectively. 21. What is your experience with corrective and preventive actions, Kappa? I manage Kappa by systematically identifying issues, analyzing root causes, and implementing targeted corrective and preventive measures. Corrective actions address immediate nonconformities, while preventive actions aim to eliminate future risks. I ensure documentation, verification, and follow-up to confirm effectiveness. By integrating Kappa into daily operations and using data from audits and complaints, I help drive continuous improvement, reduce rework, and strengthen overall quality management system performance. 22. How do you use 8D problem-solving methodology? I apply the 8D methodology for complex or recurring quality issues. It involves 8 steps: Team formation, problem description, containment, root cause analysis, corrective action, preventive action, validation, and documentation. I lead cross-functional teams to ensure comprehensive solutions and data-driven decisions. The structured nature of 8D ensures accountability, clear communication, and prevention of recurrence. It's particularly useful in addressing customer complaints, supplier defects, and process failures systematically and effectively. 23. How do you ensure compliance with regulatory and safety standards? Compliance is maintained by staying updated on relevant ISO, OSHA, and industry-specific regulations. I ensure all quality procedures, documentation, and inspections align with these standards. Regular audits, safety inspections, and employee training programs reinforce compliance. I also maintain communication with regulatory bodies when required. By integrating safety and quality management systems, I help create a compliant, safe, and efficient production environment that meets both customer and legal requirements. 24. How do you prioritize multiple quality improvement projects? I prioritize projects based on factors like risk, cost, impact, customer importance, and potential quality improvement. Using Pareto analysis and cost-benefit evaluation, I determine which initiatives yield the greatest value. I also align priorities with company goals and resource availability. Effective time management, delegation, and regular progress reviews ensure timely completion. Prioritization helps maintain focus, achieve strategic objectives, and continuously enhance the manufacturing quality management process. 25. Why do you want to work as a manufacturing quality engineer? I'm passionate about ensuring product excellence and process reliability. As a manufacturing quality engineer, I can combine my analytical skills and technical knowledge to enhance efficiency, reduce waste, and maintain customer satisfaction. I enjoy problem solving, collaborating with cross-functional teams, and driving continuous improvement. This role allows me to contribute to operational excellence, uphold high-quality standards, and support innovation in manufacturing processes that lead to business growth and sustainability. Preparing for a manufacturing quality engineer interview requires strong technical understanding and a commitment to continuous improvement. By mastering concepts such as SPC, FMEA, Lean, and ISO 9001, candidates can confidently demonstrate their expertise. These 25 questions and answers provide a comprehensive overview of what to expect and how to respond effectively, helping you stand out as a skilled, proactive, and quality-driven engineering professional.